Module 6.1. As a reminder, it's recommended to print the video script and annotate the script while watching the video for later use. Video scripts are available on Canvas. Module 6.1. How can we summarize categorical data? Why do we need tools to summarize data? Once data has been collected, the next step is to look at the data to gain useful information. Saying something useful about raw data can be difficult, if not impossible. For example, suppose a veterinarian collects information from a sample of 25 dog owners who visit her clinic. For each dog, she collects breed, age at last birthday, weight, and height to shoulder in inches of the dogs. The data are presented in this table. Without doing any calculations, can you give a good description of the dogs at the office? Many data sets contain thousands of rows. Could you easily describe those data sets? One of the goals of this course is to be able to summarize a set of data. It's very difficult to look at a table of data to see what's happening. We need a set of tools to help us summarize the data into useful forms. In this module, we will look at ways to summarize data. It is important when describing data to not focus only on the calculations. You want to focus on what the calculated quantities tell you about the data. Your goal is to be able to tell a story with the data. The graphs and summary statistics aid you in telling that story. Before describing a data set, we need a set of vocabulary to help us talk about the data set. Definitions. The objects, people, or animals in the data set represent are known as cases. In the example, the dogs are the cases. The characteristics of the cases are known as variables. In the example, the variables are breed, age, sex, height, and weight. There are two ways we are going to classify variables. Categorical variable divides the cases into groups, places each into exactly one of two or more categories. In the above example, breed and sex are categorical variables. Categorical variables can take numeric values or non-numeric values, where the values represent names or labels. Categorical variables can be subdivided. Nominal variables have no intrinsic ordering to the categories. Sex and breed are both nominal variables. Ordinal variables have a clear ordering to the categories. The dog data set does not have an ordinal variable. An example of an ordinal variable would be stress level, where the potential responses are low, medium, and high. Dichotomous variables only have two possible outcomes. Sex is a dichotomous variable. A quantitative variable measures a numerical quantity for each case. Numerical operations make sense for these variables. In the above example, age, height, and weight are quantitative variables. We'll begin by looking at how to describe a single categorical variable. We will look at describing the variable both numerically and graphically. Categorical variables are often summarized in a frequency table, which gives the counts in each category of a categorical variable. For example, looking at the dog data set, we can summarize the categorical variable breed in a frequency table. We start by drawing a table with two columns. The first column will be the breed, and the second column will be the count, or frequency, of each breed. Next, we list each of the breeds in the data set. Next, for each of the breeds, we want to count how many times each breed appears. Notice that Doberman appears 3 times in the data set. Therefore, we place a 3 next to Doberman. Pause the video and see if you can finish the frequency table located in the script of the notes. Were you able to find the following frequencies? Your turn. Use the space in the video script to create a frequency table for the variable sex. Pause the video. When we come back, we'll check the answer. Were you able to get the following table? An important summary statistic for describing a categorical variable is a proportion. A proportion can be calculated from categorical data when there are two options. It tells us out of the total how often one of the options occurs. Proportions will always be between 0 and 1. For example, looking at the dog data, we can summarize the categorical variable sex by looking at the proportion of dogs that are male. Notice that the proportion of dogs that are male are equal to the total number of male dogs divided by the total number of dogs. This gives the proportion of male dogs is equal to 0.52. The information in a proportion can also be written as a percentage. We could say that 52% of the dogs are male. Also, notice since 52% of the dogs are male, we know that 100% minus 52%, which is equal to 48%, of the dogs are not male. In other words, 48% of the dogs are female. Your turn. Use the dataset to calculate the following. What proportion of the dogs are Dobermans? What proportion of the dogs are Labs? Pause the video, and when we come back, we'll check your answers. Did you find the following? Proportions are also known as relative frequencies and can be displayed in a relative frequency table. Definitions. A frequency table is a table which looks at the counts of units in each category of a categorical variable. A relative frequency table is a table which looks at the proportion of units in each category of a categorical variable. The relative frequencies will sum to 1. For example, looking at the dog data on page 1 of the notes. For example, looking at the dog data on page 1 of the notes, we can summarize the categorical variable breed in a relative frequency table. We start by drawing a table with 2 columns. The first column will be the breed, and the second column will be the relative frequency or proportion of each breed. Next, we list each of the breeds in the data set. Next, for each of the breeds, we want to count how many times each breed appears. Notice that Doberman appears 3 times in the data set. Therefore, we place a 3 next to Doberman, then divide by the total number of dogs in the data set, giving a relative frequency of 0.12. Your turn. Finish the relative frequency table. Pause the video, and when we come back, we'll check your answers. Your turn. Finish the relative frequency table. When you come back, we'll check your answers. Were you able to find the following? Your turn. Use the space in the script to create a relative frequency table for the variable sex. Pause the video. When we come back, we'll check your answer. Were you able to find the following? Notation for a proportion. We saw in a previous module that it's important to distinguish between a population and a sample. We will use notation to indicate if a proportion is calculated from a sample or from a population. A proportion calculated from sample data is denoted p hat and read p hat. Notice that since p hat is calculated from sample data, it is a statistic. A proportion calculated from population data is denoted by the letter p. Notice that since p is calculated from population data, it is a parameter. Your turn. For each of the scenarios below, decide where the proportion is calculated from sample data or population data and give the correct notation and value. Pause the video, and when you come back, we'll go over the answers together. I want to know how American voters will vote in the next upcoming election. In particular, I'm interested in the percentage that will vote Republican. I used an online poll and got 550 respondents. 52% of the respondents indicate that they will vote Republican. Notice that this proportion is calculated from sample data. Therefore, we have p hat is equal to 0.52. I want to know how many people in Lexington City Council recycle. I interview all of the members and find 74% of them recycle. Notice this proportion is calculated from population data. Therefore, we have p is equal to 0.74. This concludes the 6.1 notes.